Okay, so in the last video, we said that this is the definition of the definite integral. So given a function, I can take this limit and I define this limit to be the definite integral of the function. And this definition was motivated by trying to find the area under a curve where f of x was above the x-axis. So this is actually equal to the area, but only, okay, let me say if f of x is non-negative. Okay, so if f of x is above the x-axis, then this is telling me the area between f of x and the x-axis between x equals a and x equals b. So this is equal to the area when the function is non-negative. So I want to think about what happens when f of x is negative, or when f of x takes both positive and negative values. So for example, let's think about a situation where f of x is just negative. So f of x is below the x-axis here. So I'm looking at it something like this. Maybe f of x looks like that. And now if I consider what's happening in this sum, so the b minus a over n is still representing that I'm breaking up my interval from a to b into n rectangles. It still represents the base of each of these rectangles. And now if I look at f evaluated at these endpoints, so f evaluated at this endpoint is this point down here, the y value is down here. And so if I draw this rectangle, right, I can still calculate the area, the base times height, right? But the area is always positive. Area is always a positive quantity, right, or a non-negative quantity. But on the other hand, if I calculate b minus a over n times f evaluated there, b minus a over n times f of this thing, this is definitely going to be a negative number, right? This is a positive base times a negative number. And in fact, it's actually like the height here, the height of this rectangle is the absolute value of f, right? So it's actually negative f of evaluated at this point. So what the integral is calculating is a negative number. What the actual area is the absolute value of that, or negative that. And so if my function f of x is negative, so if my function is negative, then this sum, plus n times b minus a over n, this sum is going to be approximately equal to the negative area. This sum is going to be approximately equal to the negative area. That's right, because all of these terms are negative. If I take their absolute value, it becomes an approximation of the area. And so this is going to be approximately equal to the negative area. And so when I take the limit as n goes to infinity of this thing, this is going to equal, well, it's still, when I take the limit, it's just the definition of the definite integral. So this is the definite integral of my function. But now this equals the negative area under the curve. So when the function is negative, the integral is calculating negative of the area. So we have to be a little bit careful. And so when I have a function that takes both positive and negative values, something like this, when I compute this sum, so forget about the limit for the moment. When I compute this sum, b minus a over n times f of a plus b minus a over n, all the way up to b minus a over n times f of a plus n times b minus a over n. When I compute this sum, some of these terms are going to be positive and some of them are going to be negative, right? So each base is positive, but the height, it depends if f is above or below the x-axis. So like in the beginning here, this is going to calculate a positive quantity. But then when I get to around here, each of these terms is going to be negative because the f value is negative, right? So it's going to add up rectangles in this region. It's going to subtract off rectangles in this region, and it's going to add up rectangles in this region. Okay, so what I'd say, let me call this area A1, this area A2, and this area A3. So this one is A1. Then this limit, well, again, this is just the definition of the definite integral. And what this integral calculates is a signed area. So it's going to add the area A1 here. So this is going to be A1. But then when I get to here, the terms are going to be negative. And so it's going to subtract off the area there. So this is going to be minus A2. And then it's going to add this area here. So this is going to be plus a3. And so when you're calculating this integral, if the function takes both positive and negative values, then the integral doesn't quite represent the area between the curve and the x-axis. It's some sort of signed area. And so you have to be a little bit careful, and you have to be aware of what the sign of your function is to know whether you're actually calculating a positive area or a negative area.